We're going to look at some examples where we'll find the derivative of a function at a number a using the definition of the derivative. In our first example, using the definition of the derivative, we are going to find the derivative of the function f of x is equal to 3x squared minus 4x plus 1 at the number a. There are two limit definitions of the derivative that we can choose, and I'm going to choose the one that has the h in the denominator. This is f prime at a is equal to the limit as h goes to 0 of f of a plus h minus f of a, all divided by h. Now we're going to substitute in. Wherever we have an x, we're going to plug in a plus h. This is 3a plus h squared minus 4a plus h plus 1 minus our function f of a, and wherever we have an x, we're going to plug in a. So this is 3a squared minus 4a plus 1. And we divide all of this by h. Now we have to do some algebra and multiply some things out. This gives us the limit as h goes to 0. I'm going to multiply this out first. So we have 3. This is a squared plus 2ah plus h squared. Now let's do some simplification. This is minus 4a minus 4h plus 1. And then we have minus 3a squared plus 4a minus 1. And all of this gets divided by h. I want to show you before we go on the most common mistake I see students make when they do a calculation like this. It's this part right here. You have to remember that this negative gets distributed to all three of those terms. Now all we have to do is multiply things out. This is the limit as h goes to 0, 3a squared plus 6ah plus 3h squared. And now before we go ahead and copy down all those terms again, let's see if anything cancels. Do you see that the minus 4a cancels with the 4a and the 1 cancels with the 1? Now we don't have to write those down again. And all we have to write down is minus 4h minus 3a squared. And then we have our h in our denominator. Let's again look and see what cancels. This term cancels with this term, and nothing else cancels, but notice these three terms. Do you see that they all have an h common to them? Because of that, we can go ahead and we can pull an h out. So this is the limit as h goes to 0 of h. We have a 6a plus 3h minus 4, all divided by h. Now our h's cancel, and we can go ahead and just substitute in that h is equal to 0, and this gives us an answer of 6a minus 4. And that is the derivative of our function at the number a. Let's now look at another example. Whenever I used to give this example on a quiz or a test, it was usually the most missed problem. I want to make sure that you understand how to do this. The following limit represents the derivative of some function f at some number a. We are asked to find f and find a. The way you want to begin a problem like this is to write down the definition of the derivative that corresponds to the limit that you're given. In part A, our limit is going to correspond to this definition of the derivative. F prime at a is the limit as h goes to 0 of f of a plus h minus f at a, all divided by h. Now what we're going to do is we are going to compare our formula to the limit that we are given. Our f of a plus h is equal to the square root of 9 plus h. Let's write that down. F of a plus h is the square root of 9 plus h, and then f of a is equal to 3. With this information, we can find out what f and a are equal to. A plus h is equal to 9 plus h. So this tells us that a is equal to 9, and then f at a plus h is equal to the square root of a plus h. We want to know what f of x is. To find f of x, wherever we see an a plus h, we're going to substitute in x. So f of x is just the square root of x. Now, this problem has a really nice built-in check, and that built-in check uses the other piece of information that we haven't used yet. F of a is equal to 3. So let's just go down here to our function and say that f of a is equal to f at 9, which is the square root of 9, which is 3, and that agrees. So we know we've done the problem right. Let's look at part B. This limit is similar to this definition of the derivative. F prime at a is the limit as x goes to a of f of x minus f of a, all divided by x minus a. Now let's go ahead and let's equate things. F of x is going to be x to the 6th. So we write down f of x is x to the 6th, and then f of a is 64. To find a, all we need to do is compare our limits. X goes to a is the same as x goes to 2, so that tells us that a is equal to 2. So we found that f of x was x to the 6th and a was equal to 2. And here's our built-in check. We're told that f of a is equal to 64. Let's see if that's true. F of a is f at 2, which is 2 to the 6th, which is indeed 64. So we know we've done the problem right. And that's it.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.